In this video, let's take a look at synthetic division. This method only works if the divisor is linear, so it's in the form of x plus or x minus c. So see how we have x minus 3 and x minus 3, like those are both in linear form. But if it, for instance, said x squared minus 3 is your divisor, then this method would not work. You'd have to use long division. But let's take a look at how we can set up synthetic division. So what you do is take this number in your divisor, see how we have x minus 3, and you want to find the root. So if you set that equal to 0 and you were to add 3, your root would say x is equal to 3. So put that in a box over to the left. Then you want to take your coefficients and make sure you have all of the powers of x represented. So I have 3, 2, 1, none. That's very important for this to work. Then you bring down 5, -6, 4, and -1. So 5, -6, 4, and -1. Leave room for a row of numbers. Don't draw that squiggly line, but just leave room there and draw a line down a little bit lower. You always want to drop down the first number, no matter what that is, to start off. So that would be 5 for this one. Then you multiply the 5 by the number in the box and bring that over underneath the next number. So 5 times 3 would be 15. Then you add those two numbers together. So -6 plus 15 will give you 9. And then the pattern starts over. So 9 times 3 is 27. Bring that over underneath the 4 and add those together. So you get 31. And then 31 times 3 would be 93. And you add those together and you get 92. So then you want to put the variables back into your polynomial. So notice you've divided something cubed by x. So you should end up with something that's now squared. You've reduced it. It's now smaller. So you have 5x squared, put 9x plus 31 plus a remainder of 92 over your divisor, which is x minus 3. So then they asked, is x minus 3 a factor? If so, why? So we would say no, there's a remainder of 92. And whenever we have a remainder, then what we divided by is not a factor. So let's look at another example. Over here I have x minus 3 again. So if I set that equal to 0 and add 3, my root is still x equals 3. So we put that in the box to the left. Then bring down the coefficients. Make sure you have all the powers of x represented. So we have 3 and 1. So we're missing a 2. So we're going to need to put a 0 x squared to hold the place for it. And then we have everything we need. So that'll be 1, because there's an understood 1 in front of x cubed. 0 to hold the place of x squared. -3 and 1. Leave room and draw a line. Drop the first number down, so that's 1, and then the pattern starts. So 1 times 3 is 3, and put that underneath the 0. Then you're going to add those together, so that would be 0 plus 3 is 3. 3 times 3 gives you 9, so bring that over underneath the next number, which was -3. -3 plus 9 gives you 6, and then 6 times 3 is 18. Bring that over underneath the final number, and you add those up and you get 19. Then you got to put your variables back in. So you started with something cubic. You divided by something to the first power, so it would make sense that now you have one less power. So x squared, give 3 an x, and then 6 is your constant, and then 19 is your remainder. You never want to combine any of those numbers that you end up with. Those are each holding a place in your quotient. And then it says, is x minus 3 a factor? If so, why? So we would again say no, because there's a remainder of 19. And whenever there's a remainder, what you divided by is not a factor. All right, so let's look at a few more. If we divide by x plus 2, then we would say x plus 2 equals 0. Subtract 2. And we get x equals -2. So put that in the box over to the left. Then bring down your coefficients. So we have a 1, 10 goes with x cubed. So let's check 4, 3, 2, 1. So we have 1, 10, 21, 6, and -8. Then leave room and draw a line. Drop the first number down, which is 1. Then multiply by what's in the box and bring that over. So 1 times -2 is -2. You're going to add those up. So 10 plus -2 is 8. Then 8 times -2 would be -16. And then you add those together and you get 5. Then 5 times -2 is -10. Bring that over underneath the next number and you add those up and get -4. Then -4 times -2 is 8. And you bring that over and add those up and you get 0. Then you want to put your variables back in. So it's always going to be 1 less power than what you started with. So if I started with a 4, my quotient starts 1 less power than that. So I have x cubed plus 8x squared plus 5x minus 4. And then I have no remainder because that last number is a 0. So just to write it a little nicer, I would say x cubed plus 8x squared plus 5x minus 4 was my quotient. And is x plus 2 a factor? We would say yes, because there wasn't a remainder. Or the remainder was 0, which means there is no remainder. Okay, let's look at another example. If we have x squared minus 28, and then they write it this way with a -1, that just means you have to move it to the denominator to fix the negative to be a +1, and then that just basically means you're dividing. So to set it up, we can still do synthetic division. So x minus 5 equals 0 gives us x equals 5 for the root. So put that in the box to the left, and then you have x squared minus 28. So that's the same thing as x squared plus 0x minus 28. And there's a 1 in front of the x squared. So put 1, 0, -28. Then draw a line. Drop the first number down. So we have 1 to get started. 1 times 5 is 5. Bring that over underneath the 0. And always add those numbers up. So 0 plus 5 is 5. 5 times 5 is 25. Then bring that over underneath the -28. And -28 plus 25 is -3. So then our final answer would have 1 less power than what we started with. So that'll just be x plus 5. And we have a remainder of -3. And you always put that over your divisor. So x plus 5 minus 3 over x minus 5 is our quotient. And then the remainder was -3. And the divisor was x minus 5. So we would say no, it is not a factor, because there was a remainder of -3. All right. So use the factor theorem to determine whether x minus 2 is a factor of this polynomial. So another thing that we can use is what we call synthetic substitution. So if you just say x minus 2 would give me a root of x equals 2, you can plug that in to just check and see if you have a remainder. So if I plug in the 2, what comes out is the remainder. I'm just going to write it that way for this step. So 2 cubed is 8, and you can certainly type all this in the calculator. 7 times 2 squared would be 7 times 4. 4 times 2 is 8, and then we have 12. So let's see, we have 8 minus 28 plus 8 plus 12. So that'll give us -20 plus 8 plus 12 will give us 0. So since all that equals 0, then I could say that x minus 2 is a factor. It's just another way you can quickly check to see if a binomial is a factor of the polynomial. You can use the root when you're given a linear factor. That is what we're doing. So if x plus 1 is given, I can plug in x equals -1 and see what I get. And what I get is my remainder. So let's plug that in and see what happens. So I have -1 cubed, that's -1, minus 5 times -1 squared, which turns into +1. And then let's see, that'll be 3 times -1 is -3, and then -2. So we get -1, -5, -3, -2, lots of negatives. So that'll be -6, -3, -2 is -9, -2, which gives me -11 as my remainder. So we know that x plus 1 is not a factor of this polynomial because I had a remainder of -11. So you could use synthetic division, but this is what we call synthetic substitution. Let me write that up here. It's synthetic substitution. You plug in the root is what we call it. Let me fix that. The root. So you're given a factor, but you've got to get the root, which is the opposite sign of your factor. So notice when they give me x minus 2, I got to plug in x equals 2, and so forth. Okay. So remainder theorem is if you have a polynomial that's divided by x minus c, the remainder is f of c. So use the remainder theorem to find the remainder when we have f of x equals 3x squared minus 7x plus 20 divided by x minus 2. So you could use synthetic division or you could use synthetic substitution. It doesn't really matter which one is quicker. They're both pretty quick. So we have 2 that would go in the box because that's our root, x equals 2. We have 3, -7, and 20. And we've got all the powers we need. Drop the 3 down. 3 times 2 is 6. We can add those together and get -1. -1 times 2 is -2. We get 18. So you quickly see that you do have a remainder. So you could say x minus 2 is not a factor based on that synthetic division. Same thing here. We could either plug in -4 for synthetic division, or you can plug in -4 into the function. So let's just do it a different way this time. So let's say 3 times, and I know my root is -4. That's why I'm plugging that in. So let's see what we get. 3 times -4 squared would be 16 plus 28 plus 20. So that'll be 48 plus 28 plus 20. So let's see, that would be 60, 76 plus 20 is 96. So we can see that x plus 4 is not a factor as well because we ended up with a remainder of 96. All right, just 2 more to go. So this one wants us to do synthetic substitution. So you just have to find g of 3, which we've done those before. So just plug in the 3 for the x. So we would get 27 minus 15 plus 2, which would give us 12 plus 2 is 14. So what you get when you plug in that number is you know that if you plugged in that 3, then x minus 3 is not a factor. So that's what that tells us because we have a remainder of positive 14. And since we came up with a number other than 0, the factor that would go with the root of 3 is not a factor. Okay, last one. So if they're asking us to plug in -4, we're seeing if x plus 4 is a factor because those two go together. The root is -4, the factor is x plus 4. But we can just substitute it in and figure out what that would be. So this one has a whole lot of exponents, so I'm just going to use my calculator to simplify this last one. So let's just carefully type all that in and see what we get. So I would just be careful you don't miss anything when you do something with this many terms. So 3 times -4 to the 4th power plus -4 cubed minus 2 times -4 squared plus -4. I'm just going to leave it the way I wrote it. And then plus 12. So I get 680. So that would tell me that is the remainder. So if they ask me what the remainder is, that's a quick way to find the remainder. And I also know that x plus 4 is not a factor if they had asked me that question, or if they say something like, what does this tell you? That's what it tells you. 680 is the remainder, and x plus 4 is not a factor. Okay, so that's it for now.